We can have more interesting and useful algorithms. So we have a lot of algorithms for sorting. You will study more of these algorithms in 331. I'm just going to briefly introduce a couple of them. The first one is exchange sort, then bubble sort. Those are the two I will talk about. We can have other algorithms like merge sort. We can have algorithms for searching. That is, you're given an element and your job is to find whether that element exists in a list. You can do this linear search where you look at one element at a time. You could do it as a binary search. So you look in the middle, then go left or right depending on whether the number is you're looking for is bigger or smaller and so on. We can have algorithms for things like computing square root. We can have algorithms that are greedy that sort of try to optimize based on what is happening, what is the best thing in the current situation, etc. So here you are given a list of n elements and you want to sort them in an increasing order. So the smallest number is first, then the next one, and so on. So here we have data. The data is the first element is 27, the second one is 63, third one is 1, and so on. Here is an example of an algorithm exchange sort. The goal here is to find the next minimum and exchange it as needed with the place where it should go. So for example, if the data is given like this, then in the first pass we are going to find the minimum. The minimum needs to move over here. That means this 27 has to go somewhere over here so that it will still be part of the array. Next time we are going to get number 9, move it over here, and so on and so forth. Bubble sort. Goal of bubble sort is look at two numbers in a sequence and push the larger number right as much as you can. So first we will look at, in the first pass, look at 27 and 63. They are in the good position, so we ignore them. Then we look at 63 and 1. They are in the wrong position, so we swap them like this. Now once we swap them, we will have 63 and 72. We are good with that, so we leave them alone. Then we will have 72 and 64. That's not the right order. We want to push 72 to the right and keep going like that. And if you do this sufficiently many times, in the worst case you will have to do this n minus 1 times, which is where n is the number of elements in the array. Then eventually the array would be sorted. Here is another algorithm called merge sort. The goal here is to divide the array into two parts, sort them, and merge them. So once you divide them, if the array is still too big, you divide it further. Keep doing it until the array is small enough that you can sort it directly. So here is an example. You have an array that has 24, 13, 26, 1, etc. It's an array of size 8. So first we divide it into two parts. Then we divide it further into two parts. When it is the smallest array that we have, that is when we have divided into 8 parts, it just contains one element, so we are done. The array is already sorted. The next thing we are going to do is we are going to combine two consecutive arrays and to merge into one. So that means here we have 24 and 13. We can order them as 13, 24. This 26 and 1 will be reordered into 1, 26. 12, 27 is in the right order, so we don't have to worry about that. 38 and 15 would be reordered as 15 and 38. The next thing we have to do is we have to merge these two arrays to create a larger array. And we can do that by looking at the minimum element over here, putting the minimum here. Then we will be looking at the minimum of 13 and 26. 13 will go here. We'll keep doing that until we merge the two arrays, and finally we will merge the array to get an array of size 8, which is the final answer that we wanted. Searching is a problem where you're given a list of items and your job is to determine whether this list contains a particular item that is given to you. We can do linear search where you search for the first element, then the second, then the third, and so on. We could do it binary, which will be faster, but in order to do that, we'll have to keep the array sorted. We'll first look at the middle element, then if it's depending on what the middle element is, we decide either to search left or search right. Once again, we have reached the check before you go ahead slide. What I want to tell you here is I'm not keen that you have understood all the details of searching and sorting. Those details are not important, just the ideas of searching and sorting are important for us. The details will be in 331.